You rely on observability to understand your system. That's the agreement we all operate under. When something fails, you go to dashboards, traces, logs, and expect to be able to follow what happened. And in simpler systems, that works. But at some point, it stops working. You can still see everything, metrics, traces, logs, but you can't explain what actually happened. You follow a request into a trace, from the trace into logs, and somewhere along that path, the explanation disappears. Not the data, the explanation. That's the break. What you're left with is activity without coherence. You see timeouts, retries, parallel processing, events triggering other events. Each part makes sense locally, but they don't explain each other. There is no single path you can follow from cause to outcome. And that's not because your observability is insufficient. It's because the system no longer behaves as a single flow. Once you move into asynchronous distributed systems, you lose linear causality. Execution is no longer a sequence. It becomes interactions over time. Retries introduce new paths that weren't part of the original execution. Queues delay and reorder work. Ownership is split across teams that only see their part. So when something fails, there isn't one story to reconstruct. There are multiple overlapping behaviors. Observability shows you all of them, but it doesn't explain how they relate. And that has a consequence. You stop reasoning about the system and you start reacting to it. You scale something, restart something, adjust a timeout. Sometimes it works, but you don't know why it worked. You've changed the system, not understood it. That's where operational complexity comes from. Not from failure itself, but from the inability to explain failure. So the natural response is to increase visibility. More logs, more traces, more dashboards. But visibility doesn't create understanding. It amplifies whatever structure already exists. If the system has a clear causal structure, observability will reflect that. If it doesn't, observability will reflect confusion. So the problem is not how much you can observe. The problem is whether the system can be followed, and that's an architectural decision. A system that can be understood has to preserve causality across its flow. When something starts, you need to be able to follow it through the system to its outcome, not by switching mental models between tools, but as a continuous behavior. That requires context to move with the system, not just identifiers. You need to know what started this, what decision it represents, and what outcome it is supposed to produce. Because if you can't answer those three things, you can't explain the behavior you're observing. And your events need to reflect that, not something happened, but what changed and why it changed. And it requires treating asynchronous behavior, retries, queues, parallel execution, as part of the system's logic, not as implementation details. Because those mechanisms redefine how the system behaves. Once that structure is in place, observability becomes useful again. Not because the tools changed, but because the system became explainable. Observability doesn't tell you what's wrong. It reflects how your system works. And if your system cannot express its own behavior clearly, no amount of observability will compensate for that. If you can't follow the system, you can't understand it. And if you can't understand it, you won't be able to fix it. That's the limit of observability. And that's where architecture starts.